to hear. Did that start again? I don't think it did.
All right, I think we know what a margin of error is. I think we pretty much hit that over and over again. Oh, we are recording. We're good. We know what that is now. Why do we need it? Let's say it out again. Why do we need it? Why do we need a margin of error? Why don't we just say, what the hell, Sean? It's 3.125. What with the cards? It's 3.125, damn it.
To reduce the chances of being wrong.
Say that again.
To reduce the chances of being wrong.
Is it Jonathan?
Derek.
Derek. Where's Jonathan? Right next to you. Okay, good. Okay, at least in the right area.
I'm actually David, though, but you're still right.
David! Where's Jonathan? There's two Jonathans in here. He's gone. He left. He had enough.
I'm one of them. But
You're one of them, but David. Okay, so David, Jonathan, Derek. Okay, Derek, you said to reduce the chances of being wrong. I like that answer an awful lot. If you simply report your center, you're pretty much going to be wrong all the time. Look back at your guys' data again. Did anybody in their sample get an average of 3.125%? Who did 94 out of 3,010? Take credit for it. Shaq, I'm going to give you credit for it.
Okay.
You got 3.12%, but 3.122, 3.123, not 3.125. In other words, nobody got the correct percentage in their sample. But almost all of you had the correct percentage within the confidence interval around your sample. Do you see the difference there? Nobody hit the bullseye on the mark. But this is the same reason people hunt with buckshot. This is exactly the same reason people hunt with buckshot. Why? You aim the rifle at whatever you're shooting, you shoot, and then what happens? It goes like this. You hit a much bigger area. You're more likely that one of those little pellets is actually going to hit what you're trying to hit. That's why you use a confidence interval. You don't have to hit it with one. You have to catch it within all. Almost all of you caught it once you included the margin of error. Nobody hit it spot on. Rick, ask me that question. You're just taking it in.
I have a question for you.
Please.
Remedial question.
No, go.
Without resorting to math and 25 words or less, could you define margin of error again?
Sure, absolutely. Actually, I'm going to turn it back to you all, though. Give a nice, short, concise answer to what a margin of error is. Give a nice, I like the answer that Derek gave. It's a way to, actually you answered why we need it, but he said it was a correction to make our answer more, to make our original sample statistic more, less precise but more accurate, so to speak. But that's not a very good math answer. That you want a mathematical answer. So who wants to fire away at what a margin of error is? I like this question. It's a very good question. Anybody? In your own words. You don't have to use mine. Please don't use mine. Use your own. What is a margin of error? What is it? We've been talking about it all day, but we haven't really formally defined it, I guess.
So it's like with the data that you've collected.
Yes.
It's kind of like what he had said too, was that it gives you more of an opportunity to be right or wrong.
I'm gonna add some terms to this board back here. What is a margin of error? So I'm going to start with a very general statement. It's an inferential to standard deviations. I'm bringing up, so you got me thinking about this when you said a little bit of a review question. In 243, we studied the bell curve.
Yes.
Which we don't even see here yet, but it's, believe it or not, there's a bell curve hidden in this data that I'm intentionally not showing you right now. What's the deal? Think back to 243. What's the deal with two standard deviations and a bell curve? Do you remember?
Yeah, because,
A little louder, Max. I just grunted over your entire answer.
95% of the data lies within two standard deviations.
95% of the data in a bell curved distribution lies within those two standard deviations. What a margin of error is a nod to that idea. And it's the inferential version, which means you don't have all the data in front of you and you can put lines up and say there's 2.5 low, 2.5 high, and 95% in the middle. It's an inferential application of that, though, where it says we're going to start at the sample statistic. and we're going to stretch out left and right from it. When we're done, 95% of any interval constructed this way will trap what you're looking for. So it's the same idea as that 243 idea of a bell curve and 2 standard deviations and 95%. The difference is in 243, you knew all the numbers. You knew all the data in a sample, and you graphed it, and you looked at the histogram, and you said, okay, here's all the data. Oh, here's the extremely high 2.5. Here's the extremely low 2.5, and here's like the more typical middle 95%. Inferentially, meaning I don't know all the data, I only have drawn a sample from my data. I have to add this correction, this margin of error correction, to increase my 0% chance of being right to a 95 or some other percent chance of being right. That was a lot more than 25 words. I think Max said it in less than 25 though. Pretty sure he did actually. But this really is the big idea of it. You take your, it's a plus or minus, right? It's a plus or minus around the sample statistic. How you calculate it, we'll get to together. That's the next couple weeks together. We're going to show you how to calculate these things for any sample statistic. We're going to use technology most of the time because it's a pain in the ass to do by hand. But for the most part, it's just a plus or minus you stack onto a statistic to create an inferential bell curve, the one that Max is talking about. And that's the step into 244 from 243. You can grow it if you want to. It's totally fine as well. Rick, is it fair? Fair for now. It might be way more than 25. I'm Italian too, I use a lot of hand motions. What the idea is if you don't include a margin of error, you're right 0% of the time. By including it, you raise your chance of catching to whatever your confidence level is. Decent for now? Keep asking questions. I love these questions. Please keep them coming. Cool.